Many experts believe that solar and wind power are more than enough to deliver any amount of energy mankind might want to demand. But are they really? What are the challenges and what are the technologies that can help us achieve a carbon-free energy supply to prevent against global warming? How do we guarantee an adequate quality of life for a growing population? Today, we take energy for granted. When we sit down to watch TV in our homes, or turn on the lights, when we turn on our washing machines, ride in the elevator to the 7th floor, electricity is almost always there, ready to serve our needs. But where did that electricity come from? How did its journey into our homes affect the environment? What should we be doing to reduce environmental impact? To provide an answer to these questions, Project ZEUS, Zero Emissions Urban Solutions, was born. Project ZEUS is based on 4 simple principles: reduced energy consumption through efficiency, incorporation of renewable energy sources wherever possible, implementation of electric urban transit, energy savings through changes in consumer behavior. To support this project, a sophisticated software platform for energy management is required. The power management system monitors energy consumption, providing users with indications for optimal energy use. It also manages renewable power sources like wind, solar and hydro to help guarantee a stable energy flow in the network. At the heart of the technology is the concept of the micro-smart grid, a subset of the energy network that is managed at the local level, feeding into the larger national or international energy grid on an as-need basis. But why the need for an intelligent system? Let's take a closer look at energy supplied from renewable sources like wind, solar and hydro. Today, these sources are being tapped into at an increasing rate. Already widely used onshore, technology is emerging which will allow us to place wind farms offshore to capture the stronger, steadier winds that blow there. Solar panels are also being integrated into local energy networks. Desolate corners of land, no longer in use for other purposes, are being transformed into commercial-scale solar stations. Sources of renewable energy don't stop with wind and sun. Biomass and hydroelectric power stations are also coming into vogue. Solar panels are also becoming a stable site on an ever-increasing number of rooftops. But what are the disadvantages, if any, to these technologies? How can this new power management system help? How does the answer to these questions fit into Project ZEUS? Over the next few minutes, we will illustrate several scenarios to highlight the challenges and importance of the new power management system and Project ZEUS. One of the most critical aspects of renewable energy sources like solar energy is that they are often unpredictable and rarely constant. A storm that rolls in and blocks the sun causes a drop in energy production. Wind can suddenly die down, leaving the wind generator at a standstill for days before a new wind comes through. Even hydroelectric power stations are subject to changes in energy productions based on water flow. In times of drought, there may be little water flowing through the bed. Energy produced from renewable sources is shown in blue. The main grid is shown in red. If the smart grid also receives energy from the main grid, its color turns to purple. What is needed is a combination of renewable sources with a stable traditional energy source to guarantee constant energy supply. The smart microgrid is based on this concept. The microgrid is a set of energy suppliers and energy users that are connected together in an optimum configuration that balances the energy supplied with energy demand. Differences in supply or demand are handled through the connections to the main network or national grid. How does the grid function? Let's look at a few examples. To reduce pollution in our harbours, many cities are asking port authorities to install ship-to-shore connections so that the ships coming into the harbour can use electricity generated onshore to supply their on-board needs. This avoids using the ship's diesel generators while the ship is in the harbour, significantly reducing CO2 emissions. But the energy has to come from somewhere. The local microgrid will be designed with these needs in mind. Energy will be supplied from renewable sources whenever available. Should there be a sudden change in energy supply from a renewable source, for example a brewing storm, the energy management system would open the line to the main grid, drawing energy to compensate for the drop in renewable energy being produced. As the storm picks up, so does the wind. The wind generators are therefore able to feed energy into the grid. The system reverts back to a closed or island mode using the renewable energy produced by the wind generator. Should the wind generator produce more energy than necessary, this excess energy will be fed into the main grid, making it available for other users at another point in the network. Would a situation like this have an impact on our private lives at home? In the future, homes and buildings will be connected to the smart grid through home energy systems, often called domotics. Using the previous example, let's have a look at how this would work. As you can see, energy is being used throughout the building. The elevators are running regularly. The washing machine is on. The microgrid is producing at optimum level. The ship comes in. Now more energy is required. According to the rules that the user has established for his home energy system, the washing machine will either remain in standby until additional renewable energy is again made available, or the system will buy energy from the main grid. The mechanisms for buying energy from the main grid have yet to be defined. The elevator, on the other hand, along with the refrigerator and other critical appliances, continue to receive energy. Electric vehicles are a key component in future microgrids. Many experts see these vehicles as a way to store excess energy. Let's look at how that might work. During the day, the solar panels charge the cars parked in the charging area. Generally speaking, the solar energy should be sufficient. If the solar energy is not sufficient, the system will call for energy from the grid. But what happens at night? That gentle breeze coming in from the shore means that our wind generators are working. Since it is night time, energy demand is low. The energy produced by the wind generator can be stored in the car batteries. The owners will find the cars ready to run in the morning. Should the wind farm produce more energy than needed, it's not a problem. Excess energy produced will be fed to the main grid. The new platform is an intelligent software system that makes real-time decisions concerning energy flow to guarantee that energy consumption within the microgrid system is always optimized, helping to ensure that energy is always available when needed. The new power management system will make an important contribution to improving energy consumption and incorporating renewable energy sources into the energy network, but it won't solve all of our CO2 problems. Government officials will have to do their part to promote electric urban transit and, more importantly, greater consumer awareness. Electricity is not an infinite resource. We all need to learn to use it more wisely. That's why Project ZEUS, Zero Emissions Urban Solutions, is being actively promoted. To ensure concrete results, the following 4 steps are needed. Reduce energy consumption through improved efficiency. For example, the use of variable speed drives on electric motors for pumps, fans and compressors can significantly decrease the amount of energy being consumed and prolong equipment life. Incorporate renewable energy sources. By relying on the wind, sun and water wherever they are available, we can reduce the need for fossil fuel energy production. This will make a significant contribution to the CO2 reduction. Electric urban transit. By using electric buses and cars, we can significantly reduce CO2 emissions in our cities and towns, improving the quality of life for everyone. But most important of all, we need to learn to save energy. By using less energy, we all do our part to protect the environment. This is an individual commitment that each and every one of us has to make if we want to achieve significant changes for the future.